And now it is my pleasure to invite Professor Dr. Alexandru Soceanu from the Munich University of Applied Sciences in Germany, who is going to talk about how to prepare future professionals for new generation network architectures.
Yeah, good morning. Can you hear me, everybody? Okay, thank you. I come from Munich, and I am prepared to introduce you our ideas about how to prepare future professionals for new next generation secure network architectures. And first of all, thank you for the invitation me. Thank you to the organizing committee for inviting me here to give a keynote address. And secondly, greetings from Munich. We are saying very often that actually Munich is a secret capital of Germany, even though some others do not accept that. But however, the problem with the new generation is that if we compare that to the human being, the difference between the between the father, the daughters, or the sons and the grandfather is around 25 years. If we make a comparison between a grandfather and the son, then we'll be about 50 years. 50 years for IT is an eternity. So we have to look into the new generation which appears into the technology very often and not wait 50 years. By the way, I had a slide with the WWW, which you mentioned today, that's 30 years long, but 30 years long is for the new generation already too old. So we have to look into different type of technology. So what do we hear today around us? Everything is new, is advanced, is plus, is smart, is next. So the same also in the network technology. So I took a look into the network state of the art, and what you see there, you see next generation assets, next generation firewall, next generation intrusion detection. Then you see new generation network technology like network virtualization, network visibility, network function virtualization. The next group of advances, new generation software-defined anything. Software-defined network, software network security, software-defined anything. So we are in an era of new, next, advanced, smart, plus, and we should look from the network architecture point of view what is all about and how can we prepare our professionals for these new generations of technology. But it's not only the technology which is a problem. The problem is that today there aren't simply enough trained network security professionals. Right now, only in the US, 112,000 unfilled openings for information security analysts. Estimations are saying that up to 3.5 million cybersecurity job openings in 21. I remember I attended that conference 3 years ago, and one of the presenters here said, if you are able to spell security in the United States, you get immediately a job very good paid. I believe that is still the fact, but to that, you should add another attribute to be able to spell artificial intelligence, machine learning, and orchestration. Okay, we will come to that point. What do I intend to present? A short review of the major next and new generation network architecture technology. I will not bother you with too much technology. And because of the rapid rate of technology change, the educational institutions are on high alert. That means they have to be prepared to educate their students for that new technology. And I will present from our point of view at Munich University, how did we start to solve that or to offer some solutions. And at the end, the achievement of an appropriate level of expertise through effectively turning theory into praxis. A short conclusion. Okay, so if you look at the organizations today, you will find following situation. For the small and mid-sized organization, they are fighting, administrating a mixing of two types of technology concepts. One of it is generic network architecture with all these hardware assets, routers, switches, hubs, load balancer, and so on. And they are adding permanently new generation, next generation network components like new generation firewall, new generation IPS, new generation sandbox, and so on. The other set of organization, they are data centers, cloud centers, network providers. They moved already, almost most of them, to the next generation network architecture technology in order to reduce cost, increase efficiency, improve service offerings. So that's the situation out there. And now, let me introduce you how everything started actually with that new technology. The separation of the functionalities from the hardware and simulate these functionalities became a virtual instance, and in that fact, we created so-called network virtualization. And that means the network is virtual. It is not something which you have box over the box into I don't know what kind of room, which have a lot of, which are using a lot of electricity and so on. So we speak about logical virtual network. And a logical virtual network runs on top of a virtual machine. So if you don't talk about virtual machine today, you are not an engineer. Okay, so you have a lot of advantages for that. You have only a single hardware platform. You reduce cost and create virtual network within a virtual environment. And we took advantage of that, and I said already for 5 years, and we said, okay, we are offering to our students a virtual box. And within the virtual box, we have a virtual, we have a network. It was a simple network, a basic network based on 6 subnets with 4 routers, 2 PCs, and all of them connected via what we are calling virtual local area network. That means from one PC, you can see every message running around. And in that case, you are able to understand how everything is working on your own computer. Okay, all this configuration, which even can be extended, no problem, put on an Oracle virtual box, and you have it on your hands, and if the instructor is configuring all this devices, routers and PCs, that the students are not bothered with installation, a lot of operating systems and features. The students are doing nothing else but execute the assignment, which are based on this equipment. A little bit of information where you are, and we have a red cube. We are known as a red cube in Munich. So, now, after we know that we can virtualize a lot, then they started to virtualize the functionalities. That means it decouples the network functions from the hardware with a lot of advantages. In that case, we speak about network functions virtualization. That means not only the network, but also the functions of the network can be virtualized and introduced into a network. So, but after you virtualized everything, after you have the network at your hands, you want to see what happened within the network. So you need the visibility of all the data running around. And this is also required for improving network security, because any hacker who is coming into a network can be observed and can eventually be blocked. So, network, we come now to the point of saying advanced network visibility, and this advanced network visibility allows you to improve network security with a lot of advantages, control the activities, detect security breaches, accelerate the identification of threats. And now, of course, this idea of having visibility in the network, we are calling monitoring. So monitoring is not very new, but was necessary to be, again, advanced, because only to look at what the data are traveling and where the data is not sufficient if you do not analyze this data to find out if somebody who came from outside without being allowed to will go into your network and do something which you don't want to have. So we speak today about advanced network visibility approaches. And one of the method which started now to be very up to date is a next generation security information and event management. That is based on a computational analysis of large quantities of logs using analytics, as I said before, with some components like machine learning, behavior profiling, statistical analysis, and the data are collected very much, a very long, very large type of data which are traveling the network have to be analyzed, and you have to also analyze the performances. Within that area, there are some products which are also open source or commercials. Now, another solution for the same idea of visibility is a next generation security orchestration, automation, and response. Seems to me that some of the students or some of the developers of this next generation package or software were present at the presentation of Melissa, who offers them the possibility to understand how an orchestra and a concert are working. And because they don't want to speak about management anymore, we speak about advanced activities, they speak about security orchestration. By the way, the word is now very much used for this type of software packages for helping the visibility. So this collects security threats, this selects incidents and accelerates threat qualification, investigation, and response. Okay, with very good results, detects and responds quickly the cyber incident, reduce mean time to detect, mean time to respond. I had a look into internet. There are more than 20 vendors offering this kind of software. Some of them are open source and some commercial. Just one comment here, very interesting. 2 weeks ago, Palo Alto Networks acquired one of these startup company, the Misto is called, for $560 million US. It's probably not new for America, but I just mentioned that because we do have Palo Alto Networks Academy program, and I hope that they will offer us also the possibility to work with that. So, now, referring to Palo Alto, Palo Alto is a quite successful company next to Cisco, and we had to look into that, and they came to us, and we are now a partner of them, and they are able to support our students with some of the products which they have, but all virtual. Of course, now I come to the next generation of assets. Apart from visibility, one of it, which is very important, and I don't believe that today we do have any network which does not contain a firewall, but we speak about next generation firewall. Next generation firewall adds a lot of features to the legacy firewalls, like visibility, detailed analysis, advanced persistence threats, embedded IPS, data filtering, so quite a lot of features which are absolutely necessary today. A short view of Palo Alto Networks. They didn't invite us yet to Santa Clara, but I hope next time. Here is an implementation architecture for educational purposes, which we did for extending what I showed you before, this type of basic networks. We added now here an open source next generation firewall from Untangle, and we put it here to do a comparison with the open source, a network generation firewall from Palo Alto, and connection to the internet, so the students have the possibility to work on that with different assignments. Now we come to the next type of next generation, new generation malware detection, which we speak about sandbox. You know that this is very interesting. I love very much how the Americans are find the new words. So they decided that the same like the children are playing in a sandbox, why should we not play in a sandbox, which is not the real computer, our files which we do not know if they contain malware or not. So, and that is the idea. After I do analyze this in a sandbox, I decide if it's okay or not and let it introduce into the network. We are using a commercial, we are using a open source software which is quite known, cuckoo sandbox. And this cuckoo sandbox, just for your small information here, if you have a malware file, you go through the firewall, but the firewall will decide that it does not know exactly if that file contains or not a malware. So it's transferred to FTP server. FTP server is sending to the sandbox. The sandbox does the analysis and send back the results saying that it is a malware or is not a malware. And if it's not a malware, can be transferred into the intranet. In case it's a malware, can destroy it or maintain in the quarantine. So that is the idea behind it. And that is another step ahead, which we have got it from Palo Alto, of course. Palo Alto is doing a little bit more sophisticated concept. They do that on a cloud. And if the firewall signals that is an unknown sample which are supposed to be analyzed, then is transferred to the cloud, and in the cloud, based on a lot of concepts like static analysis, machine learning, dynamic analysis, network profiling, dynamic unpacking, is established if that is a malware. In case it's a malware, then this type of file receives a signature, and this signature is transmitted to all the customers from Palo Alto network, in order to be sure from the right beginning that this file should not be analyzed anymore and classified as a malware. Okay, now I am not finished with all these advances. There comes the next generation intrusion prevention system. And this combines again all the features from the old firewalls and the IPS. But the major feature of such an intrusion prevention is that it looks into the context of the message, not only on the header, but also what the message is transferring. That means the context and the content. And it has quite a lot of other features, like, for instance, if you have web applications, it looks at buffer overflow, injection flows, cross-site scripting, and so on. So we decided, for educational purposes, to use a well-known IPS, which is under the name snort. Probably you have heard about it. And very interesting is that Cisco acquired that packet, the software, and improve it a little bit. And they even say that what they are selling is based on snort. So we are very good for our students. That means they get experience on that. So the snort is played after the network firewall, new generation file. Okay. Of course, now, if you, like we have heard yesterday, if you want to access resources to a network, that means you have to prove who is doing that, and if he has authentication and authorization. And for that purpose, we are using a quite, let's say, traditional type, which is known under the name radius. So we have a radius here, which is controlling the access to the network resources, which we have it again on our network for the students. But not only that, there are some other concepts, which is not that new, but is quite used, which is standardized by WASs and can be programmed using XHTML. And we are speaking about access policy technology. And I give you here an example which our students are expected to solve. Supposing you have a number of subjects who would like to access resources in a hospital, simulated, of course, electronic health record containing different information. So, in order to get the access, you have to prove that the subject has an access policy which allows him to access that. And we use, in connection with the University of Eindhoven, a policy engine server, which is public, and we put here quite a lot of policies for different type of subjects. And if a subject is required a resource, then this interface here will ask the policy. If the policy corresponds to what is expected, then this subject gets the reply back for permitting or denying. Okay, so now I come to another evolutionary point. We speak about software-defined networks. This is something completely new. That means we do not have the traditional components, assets like we had up to now. So the whole network consists out of a control plane and a forwarding plane. The control plane is able to control all the components which are within that network. I give you with a lot of advantages. I give you an example for where our students are working. That means they are able in a very short time on a virtual machine to create a network like this. You have a controller here, you have a lot of switches, and you program these switches from the controller to be able to allow different accesses to the servers. That means these switches they are not programmed from initially, they are just dumb system, can be programmed from the controller and change every time when they need it. So that is a new idea, and this idea is already, or this concept and technology is already introduced in the very large data centers. Okay, we are also made some experimental on that. Now I came to the point where I want to present you the reference model, which is our solution, which we are offering to our students locally as well as remote, because we can't do it online. And if we want to teach students, engineering students, you cannot teach them just offering tutorials and materials and books. You have to offer them labs. And if you don't offer them labs to have the possibility to have hands on them, they are not sufficient prepared. And I have here a set of, just for this reference model, a set of new next generation components which are introduced into our network. And the network looks like this. That means we have two demilitarized zones, like we call it. One is here and the other one is here. That means we have three net generation firewalls. We have web server, we have FTP server, we have sandbox. We have three types of monitoring system. We have IPS, we have radius, we have a database server, and an intranet, which can be extended anytime from the students adding additional components. probably will ask me now, hey, if you put all of this onto a computer, how much memory do you need? We made an appreciation and we started to offer solutions for that. The memory requirements for what I showed you here is around 16 gigabytes. But 16 gigabytes, okay, our students, they are rich, but not that rich that they have this kind of laptops with 16 gigabytes. However, they don't need it immediately, everything. So we have three solutions. The first solutions, we have pre-configured virtual machines with some components because they don't have to experiment all of these devices, only one at a time. And we do have these components already configured in a Google Drive or on a public FTP. They can download this and have it on their own computer, take it home, take it in their vacation and work on it. The second solution is based on a hypervisor server which is placed at our university, and they can access it by using Moodle, also from remote, but don't have it on their own. The third solution is based on OpenStack. That means is a larger platform where we can introduce much more virtual machine images. And in that case, we do not have any memory limits, and we do not have limits of a number of students who are able to access this in parallel. And I have here some information. That means if you have to teach a lab where the students, you have, let's say, in a lab, 20 students, each student need a platform. That means we can start also 20 platforms. Each one is working on its own in order to be able to solve the task, as well as also on its own computer. Another version, which are offering for research development, we are offering quite a virtual machine pool on an OpenStack. And the students, depending on the project which they have, they can take these components, put them together, and do the task. But I repeat, all of these components are already configured so that they don't spend time to do that. And because we have to offer this, not only to our own students, we have since 3 years a project which is already on place, and we call it Open Distributed European Virtual Campus on ICT Security. There are 6 universities. Each university developed one course, and all the others are able to access and work on that course. This platform contains for each course also a lab. And I give you here the example, a course which I teach for secure network management and computer networks based on all this equipment which I showed you and the software, and all the other students from the other universities are able to access that and using also Moodle. Okay, so in conclusion, I consider the virtualization technology unleashed an avalanche of new concepts, marking the advent of the virtualized network architecture era. And the network virtualization allows software to decouple from hardware, motivating developers to create next-generation network architecture tools, which are coming to us every day almost. This process is being accelerated by organizations who are needing necessary tools for protecting their network security. And virtualization have paved the way for flexibility by offering new generation network security professionals hands-on, complex, online virtual labs. And of course, with a keen awareness of the budget constraints associated with such sophisticated labs, Munich University key implementation present here are mainly based on open source software, and where we add this academy program from Palo Alto Networks. Thank you.